Hello, people. This video segment is the concluding remarks on the material in sections 4.4 and 4.5. So, let me remind you what these two sections were about. 4.4 and 4.5 dealt with solving trig equations. Now, in 4.4, you were told that regardless of what equation you're given, you got to bring it down to the so-called basic trig equation. And a basic trig equation is something like that. Sine theta equal to, let me use some specific numbers here, for example, 1/2. Cos theta equal to, maybe minus root 2 over 2. And tan of theta, I'll give a specific example, say root of 3. Okay, you might say, well, wait a minute. What happened to secant and cosecant and cotangent? Now remember, if cotangent is given, let's hypothetically say 5, then tangent is 1 over 5. Or if secant is given, say 3, then cosine is 1 over 3. So this is why we're not going to worry about cosecant, secant, and cotangent. This is the only type of equation that we're going to worry about, this type of thing. And what I'm going to do is I'm going to start with this first one and do it completely and talk about it. And then maybe we go to the next one and finally the last one. So let me start with sine of theta equal to 1/2. The first thing that you realize is that the period of the function sine, period of the function sine is 2 pi. Okay, so you have to decide on an interval of length 2 pi. Sorry about this. Interval of length. Okay, I guess I'll go to the next page. Interval of length 2 pi. For example, you can say, all right, I'm going to concentrate on 0 to 2 pi. This is length 2 pi. Or I'm going to concentrate on, for example, let's hypothetically say pi and 3 pi. That's fine. Or you can say from minus 2 pi to 0. See, these all have length 2 pi, and it looks like this is perhaps the easiest one to concentrate on, at least for now. Okay, so find two solutions of sine theta equal to 1/2 in the interval that you concentrated on, and you decided that it was 0 to 2 pi. Okay, it could have been any of those other things that I wrote down, but you decided on this, which is fine. Now, immediately you can write one answer. It's pi over 6. Because sine of pi over 6 is in fact 1/2, and this pi over 6 is in the interval 0 to 2 pi. Now let me also show you what you have done graphically here, or in terms of unit circle. So this is the cosine axis, and you said that cosine is 1/2. Sine is 1/2. This is the sine axis. This is the cosine axis. You said that sine is 1/2. So what you did, you actually wrote this angle. You wrote this angle, pi over 6, which is fine. But notice that there is another angle in this interval 0 to 2 pi. In fact, it's exactly on the other side. In other words, in quadrant 2, this angle, which happens to be incidentally 5 pi over 6, because you go by the length pi, and then you back up by pi over 6. So pi minus pi over 6 is 5 pi over 6. So that's what you did. You found two solutions of this in an interval whose length is the period of the function, which is 2 pi. And therefore, we are pretty much done. There is nothing else in that interval. There is no other angle in this interval whose sine is going to be 1/2. Nothing else. And therefore, the general solution, or let me call, actually the book calls it all solutions. These are two specific ones that we found. All solutions are these two. So you take pi over 6 plus 2 pi times k, okay? And theta equal to 5 pi over 6 plus 2 pi times k, where k is equal to 0, 1, plus or minus 1, plus or minus 2, plus or minus 3, etc. Okay, so let me try another one. Let me try this. So sine of theta equal to minus root 2 over 2. Okay, so period is 2 pi. Concentrate on an interval of your choice. Interval of your choice. But make sure that the length of that interval is the period of the function, such as 0 to 2 pi. As I said, it doesn't matter what interval you take, but make sure the length is 2 pi. However, it is very easy to do 0 to 2 pi probably because of what we already know in terms of trig circle. Okay, good. Now find two solutions of sine theta equal to minus root 2 over 2 in the above interval. Okay, well, you can always use your, if you know you're good in the trig circle, you have memorized some of these standard angles, you know minus root 2 over 2 is somewhere here, minus root 2 over 2 is somewhere here, and the angle is actually this, right? Now, I could have, by the way, said minus 3 pi over 4. See, minus 3 pi over 4, this is also minus 3 pi. But minus 3 pi over 4 is not in that interval. You decided to go with 0 to 2 pi. If that's what you did, whatever you write down must be in here. So one angle is in quadrant 3, which is pi plus pi over 4, which is 5 pi over 4. The other one is right on the other side. You see that? In quadrant 4. Let me go here. On the side, there. The other one is this angle. The other one is 2 pi minus pi over 4. So that's a 7 pi over 4. And you did it. In other words, these two angles, one happens to be in quadrant 3, the other one happens to be in quadrant 4, and all solutions are, now just add multiples of period this thing. Theta equal to 5 pi over 4 plus 2 pi k. Theta equal to 7 pi over 4 plus 2 pi k, where k is equal to 0, plus or minus 1, plus or minus 2, etc. Okay? So, let me do one with tangent. All right? So, tangent of theta equal to, let's say, minus root 3. That's what I wrote down. Okay? So, period of tangent is pi. So take any interval. Take any interval of this length. For example, you can do 0 and pi. No problem. You can do minus pi over 2 to pi over 2. No problem. You can do, oh, I don't know, minus 3 pi over 2 minus, the pi here, minus pi over 2. These all have the same length, period of the function. So, you know what? If for tangent, you know that this is very nice, right? Just like for sine, 0 to 2 pi was nice, okay? So I'm not going to worry about this. So first thing that you do, find theta such that tan of theta equal to minus root 3, okay? And it is in the interval that you select. Right there. Now you can always use your calculator to your advantage if you want, but you're going to get theta equal to minus pi over 3. Believe me, minus pi over 3 is in this interval. Try it. And tangent of theta is minus root 3. If you don't believe it, try it. So this is the only solution. For tangent, you just look for one solution. For tangent, just look for one. And we did it for one solution. Remember, for sine, we had to do 2. But for tangent, we just do 1. And once you found it, it's in that interval that you picked, okay, of length pi, then you're done. All solution is whatever you found plus pi times k, where k is equal to 0, plus or minus 1, plus or minus 2, etc., plus or minus 3. Okay? The key is for tangent, you look for one solution. And it is usually very easy. So, look, okay, let's say for tangent, choose for your interval. In majority of the cases, this is going to be a fairly good choice. Interval minus pi over 2 to pi over 2. Notice that this is length L, length pi, as we expect. And look for one solution. And once you found that solution, then take it and add multiple of pi to it. K equal to 0, 1, 2, etc. Okay. For sine and cosine, as the interval, usually it's the best one to choose 0 and 2 pi. Choose 0 to 2 pi. And look for two solutions. And once you found it, 2 pi k, and the other one, I'll call it theta 1 and theta 2, 2 pi k, k equal to 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. All right? Now, yeah, so that's pretty much it. Hopefully this will help